Hey everybody, Mrmathblog here. This lesson you've probably seen before. It's called Slope-Intercept Form of a line. If you haven't, it should go pretty easy. Don't forget all your lessons can be found at Mrmathblog.com. Just make sure you click the Integrated Math 1 link at the top. Alright, slope-intercept form of an equation is y equals mx plus b, where m is your slope and your y-intercept is that b right there, and it has the ordered pair 0 comma b. So this is where it intersects your y-axis. Remember, your y-axis is the one that goes up and down. And then the slope is, we can use slope formula for that, or use a picture if we did that. So we'll have examples of both of those. So write an equation of each line in slope-intercept form. So we want to write it in y equals mx plus b form. Okay. So the slope is 3, and it goes through the point 2, 5. Okay, so this is your x, this is your y, this is my m right here. So we need to figure out b. So we know the slope is 3, and we need to find the y-intercept b. So since the slope is 3, we can put 3 in for m right here. So y equals 3x plus b. Okay, easy enough. And then we can substitute. Let's just slide that up. The point 2, 5 in for x and y to get b. Okay, so 2, 5. Remember, it always goes in alphabetical order. This is x, this is y. X comes before y, so this is x. So x goes right here next to the 3, and then 5 goes right here. And that's what this says right here. All right, so 3 times 2 is 6. So now we're going to go ahead and subtract 6 from both sides, and we get b equals -1. All right, so that's the ending. We just got to put that right there. So it's going to be y equals 3x minus 1 is that one right there, okay? So there it is right there, y equals 3x minus 1, okay? All right, easy enough. Let's try it with this one. This time the line passes through 0, 5 and 2, 13. Well, remember, this is 0b, so this is the y-intercept right here. We'll use that as a shortcut right here. Your b doesn't do that. All right, remember, I'm sorry, your book doesn't do that. Remember, slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we'll let this be x1, y1, and this be x2, y2. And you can flip them around the other way if you want. You can make this one x1, y1, and this one x2, y2, but it doesn't matter. I think we're going to make this x1, y1, and then this x2, y2. And we're going to plug it into the slope formula right there, so we get 4. Okay, so now we know y equals 4x plus b. And since this is b right here, 5 right here, then it's going to be y equals 4x plus 5. Okay, so that's the answer right there. Piece of cake. All right, how about if it passes through these 2 points? One of these are not b, so we got to go ahead and keep going. So let's go ahead and do slope formula again. So slope formula is going to give us 7. And then we substitute either point, you guys. It doesn't matter which point we substitute in. I like dealing with smaller numbers, so I'm going to substitute 1, 4 in. I think that's what your book does too. All right, so then we get b, when we do all our math correctly, it becomes -3. So here's the 7 that goes in front of the x. Y equals 7x minus 3. So y equals mx plus b, which is 7x minus 3. Too easy, huh? Write each equation in slope-intercept form, then graph the line. Okay. All right, well, this one's already in slope-intercept form right here. Okay, so what we're going to do is use the slope, which is 5, and that's 5 is 5 over 1. 5 over 1. This is rise over run. Okay, so we're going to go ahead and plot the y-intercept first, you guys. So we'll plot -4. So that's going to go right down there. Let's plug that because it crosses the y axes at -4. Okay, now we're going to use this slope. We're going to use the slope up 5 over 1 and plot another point. Okay, so up 1, 2, 3, 4, 5 over 1 and plot another point. Okay, and then we just connect those 2 points with a straight line, and there it is right there. So here it is in slope-intercept form. It already is written in that, and then it says graph the line. So there it is right there. Let's try another one. Okay, this one is not in slope-intercept form. Okay, so what we have to do is solve for y. So we're going to go ahead and subtract 2x on both sides, and we get that equation, and then we're going to divide by 6, by this 6 right here, because we want to solve for that y right there. So when we divide by 6, -2 and 6, they cancel out because 2 goes into -2, -1 time, and 2 goes into 6 3 times. So we'll change this to a -1 and change this to a 3. Both of these cancel. This cancels to 1. I should have wrote a big fat 1 right there. And then these cancel here. So it's y equals -1/3, don't forget your x, plus 1. Y equals negative 1/3 x plus 1. All right, now we graph this. The plus 1 is going to go right there, and then from there we're going to use our slope, okay? So let's go ahead and we're going to plot b equals negative 1 and then use the slope, which is negative 1/3, which means we're going to go 1 down and 3 to the right. So if that's negative, that just means we go down. Always go to the right with the bottom number. Always go to the right. So if it's positive, we move up, but if it's negative, it moves down. So down 1/3. So we're going to plot b. I think I did it one at a time. So there's b. And then now I'm going to go down 1/3. Okay, see here we went down 1, and then 1, 2, 3, and then we connect them up. That's our line right there. Okay, so here's our equation, and here's our graph right here. All right, so identify the slope and the y-intercept of the graph that represents each linear situation and interpret what they mean. Then write an equation in slope-intercept form and use it to solve the problem. Okay, so here's one. For one taxi company, the cost y dollars of a taxi ride is a linear function. Linear means y equals mx plus b, for today anyways, of the distance x in miles traveled. Okay. The initial charge is $2.50. This is our B. Okay, and the charge per mile is 35 cents. This is our M. This is our rate of change. Every mile it changes by 35 cents. So find the cost of the ride in the distance of 10 miles. Okay, so the rate of change is at 35 cents, so that's our M, 0.35. Okay, so the initial cost is $2.50. That's our y-intercept, $2.50. All right, so our equation is y equals 0.35x plus 250. So now to find the cost of riding 10 miles, we just plug in 10 for x right there. When you multiply it by 10, it just moves that decimal over one place to the right. So that's going to give us 3.5, and then 250 is just 2.5, so 3.5 plus 2.5 is 6. All right, now what's that mean? Well, it means that 610 is the solution to the equation, and the cost of riding a distance 10 miles is going to be $6. Okay, that's not too bad, huh? All right, let's try another one. A chairlift descends from a mountaintop to pick up skiers at the bottom. The height in feet of the chairlift is a linear function, y equals mx plus b for this lesson, is a linear function of the time in minutes since it begins descending as shown in the graph. So it starts here and then it starts descending right here. Find the height of the chairlift after 2 minutes. So here's the time in minutes, 2 minutes right here. Here's the height in feet. So these ones are going by 600 right here. All right, so we want to figure out what is this point right here. Well, we can make a guess right here. It looks like about, let's see, if that's 3,600 plus 6, that would be 4,200. So it's halfway in the middle. Well, let's figure it out mathematically. Let's find the slope, you guys. So the slope is negative 750. Let's see, we did y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is negative 3,000 over negative 4. Negative 3,000 divided by negative 4 is negative 750. Okay, so this represents the rate at which the chairlift descends. For each minute, it drops 750 feet. That's a pretty good little speed right there. All right, so the graph passes through 0, 5, 400. So the y-intercept, or 5,400, 5,400, boy. So the y-intercept, this is the y-intercept right here. See where it's intersecting the y-axis right here? So this is our b, 5,400. So our equation is going to be y equals negative 750x plus 5,400. All right, let's slide that up right there. Now it says find the height of the chair 2 minutes after it begins. So we're going to plug in 2 right there. So negative 750 times 2 is going to give us negative 1,500 plus 5,400 is 3,900 feet. Okay, so 2 comma 3,900 is the solution to the equation, and the height of the chairlift after 2 minutes after descending is 3,900 feet. Okay, and there's the point right there. All right, so a couple of questions to wrap this up. So in the example involving the taxi, how would the equation change if the cost per mile increased or decreased? How would this affect the graph? All right, well, we didn't do a graph on that, but increasing the cost per mile would increase the value of m, which is our slope, and when that increases, it makes the graph steeper. Decreasing the cost per mile would decrease the value of m, and that would make the graph less steep, even though we didn't graph on that. What are some advantages to use the slope-intercept and some disadvantages? All right, well, in graphing, it's easy to recognize the slope and the y-intercept. It's also easy to find y values because it's y equals mx plus b when they give you a corresponding x value. A disadvantage might be that the x-intercept might be hard to see, or if they wanted you to find a y value, it may be harder to get the corresponding x value. Okay, if they give you the y value and you're solving for the corresponding x value. All right, gang, if you are in my class, I would assign you that homework. Take care.